Does the second law of thermodynamics apply to open systems? Have you ever wondered how the second law of thermodynamics fits into the world around us, especially in open systems? Let's break it down in a way that makes sense. The second law tells us that the total entropy, which is a measure of disorder, in an isolated system can never decrease. It can only increase or stay the same in perfect conditions. But what about open systems? Open systems are different because they can exchange both energy and matter with their surroundings. This means the second law still applies, but we need to think about how these exchanges affect entropy. When energy, like heat, moves in or out of a system, it can change the system's entropy. If heat enters at a high temperature, it can increase disorder. If it leaves at a lower temperature, it might decrease disorder. Now let's talk about mass transfer. When matter enters or exits the system, it brings its own entropy. This is important because the overall change in entropy for an open system includes contributions from heat transfer, mass transfer, and any internal processes that create entropy. To put it simply, the rate of change of entropy in an open system can be represented mathematically. The formula includes the rate of heat transfer divided by temperature, the rate of entropy from mass flow, and the rate of entropy produced inside the system. The last part, which accounts for irreversible processes, is always greater than or equal to zero. This ensures that the second law is not violated. In practical terms, even though an open system can locally decrease its entropy, like how living organisms create order, the total entropy of the universe still increases. For example, when a plant grows, it organizes matter, but the process of photosynthesis and respiration creates more disorder in the environment. So yes, the second law of thermodynamics applies to open systems. It's essential for understanding how real-world systems work, like engines, refrigerators, and even ecosystems. By considering how heat and mass flow affect entropy, we can better grasp the principles of thermodynamics in our everyday lives.